Hey there, folks, and welcome to the 37th edition of the Hasura Community Call. This is launch day. My name is Rob, and I am your host for this October community call. And we're going to go ahead and dive into our agenda and see what we have in store for today. We have a packed agenda as normal, and we're really focusing more than anything on connectors today. So you'll see some information about how to build your own connector, some new connectors that we have built and that we built with some partners. We'll get some information on our TypeScript connector and incorporating custom business logic. And then we have somebody from our solutions engineering team coming to talk about end-to-end observability using open source tools. So that will surely be exciting. And we'll wrap everything up with a community demo from Raphaël about how we can develop with Hasura using Gitpod, so in the browser. Very cool things there. To begin with, I'm going to go ahead and bring a familiar face to the stage of Rahul, and he's going to be joined by Phil. Awesome. I'm going to turn it over to you folks. And Rahul, I think you're going to start off for us, and then Phil's going to give us a demo of some information about how to build our own connectors.
Yes, please.
All right.
So we are excited to talk more about learning how to build your own connector. And but before we, I think, deep dive into why, how to build a connector, let's talk about why build a connector. And the reason is performance. And that's why you've been using Hasura. You love Hasura because of the performance promise it provides you, especially with the GraphQL query. And the reason is that we have a no resolver approach to GraphQL execution. In fact, we convert the entire GraphQL query into a single SQL query, which means those many less calls to the backend data source. And that is where I think our point of view lies in terms of building performance and production grade APIs. In fact, we just launched a blog where you can go in detail on the benefits of compiling GraphQL for optimal performance and not relying on ad hoc and client-driven approaches like data loader. So just kind of explaining the reason why we have invested so much in building connectors and extending that capability to the community via the native data connector specification. And deep diving a little bit more into why, as a developer, you would benefit by working on a connector over a resolver. And the reasons are in front of you. You get a structured development environment with fixed types, and you're able to leverage the native capabilities of the data source. The challenge in API development these days is selecting the right data source for your use case, and then leveraging all those native capabilities in the API server layer is where I think the magic starts. Thirdly, handling state and advanced scenarios. State is something you will get the moment you go to production and you have a lot many users. Connection pooling and multi-region deployment will definitely be topics you want to be thinking about. And then client changes does not lead to rework. So the whole aspect of reusability is kind of it shines with the whole connector approach. Example, you need to model your where clause and order by once, and then any client-driven query changes don't warrant a change in your connector code. And on that lines, you could, let's say, change even your remote join strategy going forward for performance reasons and not have a whole refactor of your code done. And these are some of the aspects which Phil will deep dive into and Tristan after that. But the last 2 points here are that building a connector will give you things like distributed tracing and end-to-end performance monitoring. And lastly, once you have that monitoring and observability, you can then attempt and start working on optimization and making it even faster for your consumers. So multiple reasons of why think of building connectors and why we are investing so much in helping you build connectors. In fact, today we are launching 2 new assets. This page is going to be live soon if it is not already. But the new connector hub where you can learn how to build connectors, explore our SDKs, and see all the connectors which are live. And secondly, the ndc-learn course, which will give you a step-by-step walkthrough on how to start building a connector yourself. So without further ado, I want to give it to Phil, who will deep dive into the ndc-learn course for today.
So as Rahul said, we're announcing this new repo today. Let's build a connector under aka ndc-learn. So as Rahul said, we connectors are going to be sort of front and center in Hasura v3. So we've seen a lot of different examples of connectors on previous community calls. I think we'll see some more today. We're going to be providing some default integrated connectors out of the box. So Postgres, obviously, TypeScript, which we've seen on the community call already, which subsume a lot of the functionality that you've seen in Hasura already. So Postgres, obviously, as a primary data source in Hasura, and then things like actions being subsumed by the TypeScript connector and similar connectors. So when we say that connectors are for data sources, we say data source, data source can be quite general. It could be something like Postgres, like a relational data source. It could be a NoSQL database. It could be a set of actions. And we want to express joins just like we do between databases, between, let's say, a database and the arguments of an action. So we're trying to really combine more things under this umbrella of connectors. It could be some flat files that you have on disk in some proprietary data format that's unique to your company. But whatever bytes you have that you want to get into your Hasura graph, we want to make that as easy as possible. So we're trying to produce as many learning resources as we can, and this is the latest one. So we already, just to highlight some of the ones we already have, there's the NDC specification here, which is linked from the repo. That's here, which Rahul had in his slides. So this is more like a sort of book type format. It's very it's a specification. It's sort of very factual. You can come here use it as a reference. There's also a reference implementation that you can use as a guide. There's a section on testing. So if you want to use a sort of test-driven development, which we do in the ndc-learn repo, which I'll show, you can use these testing tools that we provide in order to make sure that the thing you're building, your connector, actually does follow the spec and meet the specification. And you can also use it to implement custom snapshot testing, which I'll hopefully also have time to show. So we have the specification, we have the reference implementation, and we have several examples, right? So here are some connectors that we have already. So ClickHouse, Quadrant, Deno, in addition to the reference implementation. So there's already quite a lot of different types of learning resources, but everybody learns differently, and we want to provide as many different resources as we can. So this is why we're announcing ndc-learn today. So this is a new short form video tutorial course that's going to go through the construction of a new connector for SQLite that runs on your local machine. We start with the basics. So there's a setup video, which is 9.5 minutes long. They're all quite short. Then we go through one feature at a time. So right now we have predicates and we have sorting. And soon we'll have more. So we're planning on doing aggregates next. After that, probably we'll take a look at relationships. Once we have relationships, there's a lot more sort of advanced predicates and sorting that we can look at. There's also things like how to integrate your connector into Hasura. So we'll do a walkthrough of that. We'll do videos on things like tracing, metrics, error reporting, all sorts of observability and things that are sort of off to the side, not actual coding, but like how we want to get a sort of best practices for integrating that connector into Hasura as well. Okay, so what's in the repository? This is in addition to the videos, which you can find under the videos directory, and each one has transcripts. This is also a TypeScript repository, a TypeScript project repository that has the code, and you can look back through each of the commits and see, step by step how each one of these things was implemented. And it's a very, very simple TypeScript project. The goal is to be as easy to understand as possible. So you can take a look through the code, and we'll walk through step by step, the construction of this connector. So I'll do a quick demo as well. Hopefully you can see my my VS Code. So this is a fresh checkout of the repository. Actually, it's just to show there's nothing up my sleeves. So I'll do an npm install, do an npm run build. Okay, so now the connector is built. It's in the dist directory, so I can run node dist index.js, and this is my connector now, ready to run. So this is sort of a standard CLI that the TypeScript SDK provides. It's the same CLI format as the Rust SDK, so you'll always this should always be familiar, no matter which SDK you use to build your connector. So I can run the serve command, for example, and it says configuration is missing. I have a configuration JSON file here, and this is a configuration for this connector, and we talk about in the videos the format of the configuration here. This is a configuration for this SQLite database that I'm going to be using on my local machine. So now the connector is running, and we'll serve requests from that SQLite database. So I mentioned test-driven development. So at each stage in the videos, we do run the test suite just to make sure that we're seeing progress and more tests turning green. So let me open a new terminal, and I'll show how that works. So here's the test runner, ndc test. It has a test command, and it will say, I need an endpoint. So you can give it the endpoint for the connector, which for this connector that I just started will be running on localhost 8100. And you get some output that looks like this. So it's going to fetch the capabilities. It says it validates OK, fetches the schema, that validates OK. Then it's going to generate some queries. You don't have to write any of these queries. It actually makes some request inputs, sort of synthesizes them from the schema that it gets. So it sees, for example, there's a table called albums. So it will issue effectively the equivalent of like select star from albums. Once it gets some rows from the albums table, now it has some data. Now it can synthesize predicate queries, right? So it sees there's a ID 1, for example. It can say where ID equals 1. And it works like this, sort of testing features one by one. So we see the features that we've implemented are passing the test. That's great. Predicates and sorting, as I said, those are the videos that we've currently covered. But we haven't covered aggregates, so that those are failing right now. I also mentioned, and you get a detailed breakdown of exactly how things failed as well. So I also mentioned that we can do snapshot testing. I can do that by providing a snapshots directory. It'll give me the same output, but now I have snapshots on disk of all of the test expectations that were generated and the requests that generated them, right? So here's some NDC query IR for a query against the albums table. It has a limit of 10, it has a where clause, and this was synthesized from the schema. We're saying where the artist ID equals 5, and we expected to see this JSON response. Okay, so we can create our own test as well. We can replay, retype out some of this, sorry. We can replay a custom directory of snapshots. So I'll use this directory as an example, but I could provide my own snapshots in this format as well. So here it's just working through these hashes of query requests, and it's saying each one is passing, it's meeting the expectation. But if they changed, then we would start to see these fail with a diff. Okay, so we can use this both as generative testing, get some tests for free, and we can also use it for custom unit testing, snapshot testing, that is, with custom files that we add. Okay, so that's the test-driven development approach that we're going to use in the repo in each video. And finally, I'll just give a quick demo of what it looks like to deploy to Hasura. I have some deployment metadata here. This is metadata for Hasura v3. I'm not going to go into details on this. There'll be documentation about all of this, but I'll show how the deployment actually works. So we can say Hasura 3, local, I'm just going to refer to my notes, sorry, local init in this directory. It gives an error, but it's actually okay. I'm going to revert the metadata to the one I already had because init is going to override it. I'm going to also create a project. Go with this metadata, and I'm going to take this project ID and copy that into my Hasura YAML file. And because I'm running an old version of the CLI, I just need to patch this. This was wrong. It should say default, not prod, but that's okay. So I'll save this and then deploy this to Hasura Cloud. There's cloud build create. I give it a project file. Hasura.yaml. It creates a build, gives me a GraphQL endpoint and a console URL. I can go there and see, fingers crossed, that this is now connected to my tunnel, to my local machine running SQLite. So if I pull albums, ID, title, artist ID, I should get some data. So this is now serving requests off of my local machine through a tunnel from Hasura Cloud down to the SQLite database on my disk. So I can say where, for example, artist ID equals 5, or let's say 1. just 2 rows. And back in my logs over here, I can see that the connector is indeed generating the right SQL. It's actually going to my SQLite database, parameterizing the query, and everything is working just fine. So that's the idea. You should hopefully be able to clone the repo and follow the steps that I just went through. In order to do the deployment steps at the end there, you will need access to the early access of Hasura DDN, and there is a link in the repo for anyone that wants to walk through this and try it with their own connector as well. If anybody wants to access DDN to try this all out, then there's an access link here.
All right, Phil, thanks so much. Thanks for switching back over to AC/DC for the artist that was returned for albums. I always like seeing that. And B, I know what I'm doing this weekend because this looks awesome. Thanks so much to both of you folks. And the next person I'm bringing on the stage right now should be somewhat familiar to a lot of us here on the community call because he has been here as a guest before. However, I'm very excited to announce that a few weeks back, we hired Tristan Haar as an evangelist here at Hasura. And he's going to talk to us a little bit about a couple of new connectors that we have that he's been working on. So Tristan, I'll let you do an introduction, and then I know that we've recorded your session, so we'll play it as soon as that's up.
Yeah, absolutely. And thanks for the intro, Rob. And I'm super excited to be here, guys. One thing I say in my video is feel free to reach out to me. I'm going to drop my email. As a technical evangelist, it's kind of my job to get to know the community and get to know what you guys want. So if you have questions or, if you just want to chat, just let me know. But with that, I'll let you go ahead and play the video.
All right, sounds great.
My name's Tristan, and I recently joined the Hasura team as a technical evangelist. Today, I'm excited to talk to you about some of the new connectors we have in the works. One of the most exciting things about this concept of data connectors is that it really opens the door in terms of what precisely we can consider a connector. Traditionally, when you think of Hasura, you probably think of instant GraphQL APIs on top of your Postgres database. As many of you, our loyal community members, know, we're already doing a lot more than that, connecting to things like BigQuery, MySQL, MongoDB, and others. The question isn't what data should you put onto your graph. At Hasura, we think the question is, what shouldn't you? Assuming that we can all agree that making developers' lives easier, allowing them to iterate faster, is generally a good thing, then giving developers easy access to all their data in one place is a no-brainer. With Hasura data connectors, pretty much anything can become a data source. NoSQL? No problem. Can you build a connector for a CSV file? Sure can. What about a vector database? Those are a hot topic right now, right? How hard is it to build a connector for one of those? I'm here to report it's not too bad. Take a look at this connector I've been working on for the Quadrant Vector Database. Before we dive in, let me give a brief explanation of how vector databases differ from traditional databases. In a traditional database, we tend to look things up based on unique identifiers. Get me customer with ID 1, for example. In a vector database, however, we don't normally look things up explicitly, but rather we search for things that are similar. When you like a movie, you don't want recommendations for that same movie. You want recommendations for movies that are similar. How do we know what's similar? Long story short, and thanks to a lot of math, that's what the vectors are for. When we create a vector embedding, we're basically capturing the isness of the thing we embed, represented as numbers. Lucky for us mere mortals, there's plenty of free and open source software available to handle this. In this example, I've taken a dataset of recipes I found on Kaggle that includes things like the steps to make the recipe and an image for each recipe. From there, I used some open source models on Hugging Face to create embeddings for both the text and the images, and then I uploaded all my data points into Quadrant. After that, it's as simple as plugging in the connector, and voila! We can query our vector database. It's quite quick, too. You might notice something a bit weird, and that each of my collections have these additional arguments for positive, negative, and vector. In this case, that's how we can perform a vector search. For a recommendation engine, It's as simple as passing in an array containing the IDs of positive and negative data points. If you wanted to perform a vector search, you could embed your data and pass the entire embedding vector to the vector parameter. Say I like this first recipe, miso butter roast chicken, but I'm not a big fan of the second one, the crispy salt and pepper potatoes. I can query for recommendations of other recipes I might like, passing in the positive and negative examples. As you can see, each of my results comes with a score, which can essentially be treated as a percentage match. What's especially cool about this is that I can also apply filters on top of this. Maybe I want recipe recommendations, but since I have some spare lemons lying around in my fridge, I'd like recipes that have lemon in the name. Well, I'm sure I could make lemonade. The recommender thinks that based on my preferences, I might be better off with roasted squash with lemon tahini sauce. As cool as this is, seeing it from graphical isn't nearly as much fun as seeing a demo use case. So you know I had to build one. What's especially neat about this demo is that I created a multimodal recommendation engine without using multimodal embedders. I discovered a novel way to concatenate embeddings into the same latent vector space. If this interests you, keep an eye out, as I'll be putting out a blog post that goes into more detail on this soon. The main idea is that recommendations for text only or image only oftentimes perform poorly. Here's an example. In my dataset, one of my data points had mismatched photo. If I like this macaroni and cheese, my top recommendation, while labeled as Southern mac and cheese, is very clearly a plate full of fish. And I'm not sure what's going on with this third photo here, but if that's the picture on the menu, I don't think I'm ordering anytime soon. Getting recommendations based only on image doesn't do much better. While I can certainly see how these images all look similar, they don't quite hit the mark when it comes to providing quality recommendations. The multimodal recommender, however, does a great job. These recommendations both sound and look like our input. In this case, we have the ability to dial down each modality. As you can see, if I turn the image weight all the way off, we get the same results as performing a text-only recommendation. I can specify exactly how important each modality is in determining the end result to recommend to the user. Pretty cool, isn't it? That's not the only thing I have to show you today. What's great about data connectors is that you can build them relatively quickly. I've also been working on a connector for Terso. Terso is based on libsql, which is a hard fork of SQLite, created by some of the same people who brought us SelaDB. Terso turns SQLite into a distributed database that works on the edge. It's a really cool concept with lots of potential applications. Having done work on SaaS applications before, I really like the idea of being able to create a database per tenant that you can affordably host and replicate in regions that specific tenant needs. On top of that, the developer experience is great because it's lightning fast. When developing locally, I'm frequently seeing sub 10 millisecond responses, which, while it makes sense, it's nice to never be waiting for things to load. This connector is still in the works, and you can expect to see and hear more about it in the near future. But I wanted to give you guys a sneak peek. As of right now, these connectors only have support for querying, and they're still in an alpha state as we've been working to develop them alongside our upcoming V3. We're planning to add mutation support in the future, and we'd love to hear from you which of the two you're most excited for. So drop that in the chat. In the meantime, feel free to check out the repos on GitHub, as these connectors are both open source and written in TypeScript. We've got lots of really cool things in the works here at Hasura, and I want to invite anyone in our community to feel free to reach out to me. I'll be dropping my email in the chat, and I'm excited to get to know more of the members of our community. As a technical evangelist, it's my job to keep my finger on the pulse in terms of what you, our community, wants. So if you have a question about the Terso or Quadrant connector, or maybe there's a different connector you'd really like to see get built, please do reach out. Thanks for watching. I hope you have a productive day, and most importantly, get ship done. See ya.
Tristan, well done. That was a great
There we
first
have it,
video.
Rob.
Yeah.
Thank you.
Hey,
Yeah.
set the bar high. I know you're going to stick around for the rest of the call, right? So if folks have questions, they can go ahead and drop them either here in the chat or in the Q&A section, right?
Yeah, absolutely.
Perfect. Thanks so much.
Yeah, of course, Rob.
All right. Believe it or not, we're going to bring Rahul back up on the stage. I've made the joke with him that he should just be a co-host with me at all times, and maybe we'll convince him to be one day so that we can just do this together and tag team it. I don't know, Rahul, what do you think about that? You and I just kind of going back and forth, a couple of cups of coffee.
Let's do a 24-hour community call and just let.
Yeah, we can be like CNN, but just for Hasura, right? Yeah.
Yes, we'll love it.
Cool. Do you want to give us a little intro as to what's going on here? Because I know we have a couple of videos since Lyndon's in Australia, right? He couldn't be up at, 2 a.m. his time, so.
Yes.
Yep.
So if there are V1 or V2 users on the call, you are also action users. And while you love the actions functionality, you've always been craving for more when it comes to integrating business logic. And with V3 beta just around the corner, you must have seen the preview which Lyndon provided of the TypeScript connector in the last community call. So we're going to just provide more developments on that front, especially on the entire local development journey of working with TypeScript functions, working with Deno, and making sure that your custom business logic, and you have a very fast REPL loop while working on your TypeScript function, so that once you push to DDN or V3, self-assured your custom business logic should work. So that's a preview of what you're going to see in the next videos. Big shout out to Lyndon for providing us a deep dive into integrating business logic.
Yeah, absolutely. And there's some cool stuff that's coming out from both of these. I will tell y'all.
Hey everyone, this is Lyndon. We're going to do a bit of a ndc-typescript-deno speedrun. We'll set up some functions, have them running in a connector locally, and then use the tunnel functionality of the Hasura CLI to be able to test it with a cloud-based console. So let's go. Firstly, let's create a little skeleton. So currently there's just this script in here, but we'll make a functions directory, touch some functions, and then echo a empty functions config. So once we've got all that up and running, we can spin up our connector. So we should be able to run this pointing to our configuration, and you'll see that by default this skeleton is the format that it's going to look for. So we'll start by writing a function. And you'll see that when we save that, our watcher, because we're using Deno watch, will refresh. And then if we code the schema, you'll see that it's not actually included there. So what we'll do now is export the function. And you'll see that exported functions are included in the schema. So now let's paste some previously defined functions in here. So if I go here and grab some other functions, and then format them nicely. And let's see what happens when we call the schema this time. So we've got our pure function foo and procedures for our impure functions. And these are making use of the fetch function that's included with Deno and hitting HTTP bin. So some other things that you can do are use structured input types. So let's define one. And then let's export a function. See that this now should be conformant, although let's change that to something that's not a reserved word. Here we go. And let's make it a little bit more interesting by combining these. And here we'll say there we go. So let's have a look at the schema now. There we go. And so you'll see that for these ones we'll have a scalar, but for this one we'll have an object response and argument types. There you go. So one limitation of HGE's engine currently, which is soon to be relaxed, is that input types can't be complicated like this. They have to be separate. So let's say that will split them up for now. And now this should be able to be used from the engine. Since we've got about a minute left, let's also show an example of maybe throwing some kind of issue or error. So if we take this one and use a union result, then you should see this will return some interesting validation issues. So when there are errors like this, it'll just assume that the result is a scalar and won't actually structure the output. So first thing, let's take out that inference issue. And what we're going to want to do next is actually create a Hasura project and spin it up and start a tunnel so that we can use this running connector to test it out from the console. So first we'll want to initialize our directory. Once we've done that, you'll see that we now have a few more files. So what we're going to want to do is edit our metadata file and reference our connector. So if we go here, then we should now have our connector referenced. And from here, we can actually refresh the data source to import the schema, which is the same as the one we were curling. And then once we've done that, we can track our collections. And so you'll see that all of the functions we have just defined should now be exposed as commands. From there, let's proceed on to our next steps. Firstly, we're going to want to ensure that we have our local service exposed via a tunnel. So you need to run this daemon. And then let's have a new shell available so that we can do more things in parallel. This tunnel create command will actually set up the cloud side of the tunnel, but since we've already done that, we can just show that it is now connected and active. So with this URL, back in our metadata, we should be able to replace this local connector URL with our tunnel connector URL. Then back in our script, we'll create a new project. That'll give us a project ID. Then from there, we should be able to go into our Hasura config and put our project ID. And then finally, we'll create a build for that project. This will give us a console URL. And if I open that in the correct browser, then you should see that we have an active build, and you can already see that we have functions that we can reference here and get the expected output. And some of them are mutations, so let's do that. And take out the query. And let's do all three, why not? So we'll start with bar, does, and QUX. Why not 1.5? Let's see what happens here. There we go. So now we've got our local connector up and running and able to be experimented with from the console. You can even dynamically change what's going on here. If you edit your functions, let's just change our foo functions to say haha instead of lol. See, it has reloaded here, performed the correct inference. If we rerun our query, then you should see that we're doing our mutations. Let's run our query instead. If you do our query and remove the mutations, then you should see we have haha coming back with no other changes required. Unfortunately, if you do want to change the signatures for any of the functions, you will need to create a new build and update the metadata correspondingly. But that's a little speed run of what it would look like to get that set up. So the really interesting thing I'll just wrap up with is that if you can kind of create sophisticated enough functions using your TypeScript connector, then you should actually be able to adopt the TypeScript connector and create a fully fledged connection-based connector with the ndc-typescript repo, which I'll link as well. Thanks, everyone.
I just want to say many things coming on DDN, and we are soon going to release it for public use, and feel free to use that form to get access to early alpha of the product, but looking forward to any feedback or as you try the product out. Thank you.
Yeah, absolutely. And folks, again, the form that he's talking about is in the chat, so you can scroll up and find it there over on the right-hand side. Thanks, Rahul. Next up, I am going to bring on my good friend Raju Sunny. I know it says that we're talking about end-to-end observability over here, but do you want to start off by talking about Ferrari's performance over this past weekend at the Grand Prix?
Thank you for that depressing note, Rob.
Sorry, had to. No, to make it serious though, right? We're talking about open source tools, which I think make a lot of people excited with regards to observability. So do you want to start us off, and then I'll get out of the way so you can dive into it?
All right. I don't have fancy pictures of food. I don't have a connector, but I do come with graphs and charts. So let's go from there.
Lovely.
All right, folks, before we get into the demo or what we are going to show you, I want to touch on what is observability. Observability allows us to gain insight into a system. Even though you might have built a system, you're not going to go back into every single line of code every time you face an issue, right? So what observability allows you is to understand and gain insight into a system without actually by just asking it questions or monitoring the signals it emits, right? To be able to ask those questions and get an expected results, the application needs to be properly instrumented. So this is what the key pillar of this is what the base fundamentals of observability is. So observability, the three pillars of observability are logs, metrics, and traces. And with combining those two, you get a full understanding, at least enough for you to survive, understanding of what is happening inside, what is causing a performance bottleneck, why am I not getting the expected results, things like that. Right? Hasura supports OpenTelemetry now for all its signals, that is metrics, logs, and traces, with one little caveat. Logs are going to be available over OpenTelemetry by release 2.35. So just hold on for another week or so for it. So why is OpenTelemetry such a big deal? It saves you time. You don't have to deal with the inconvenience of installing proprietary agents. Like your APM tool or your observability stack might come with its own agent that will reside on wherever you have deployed your application and ships data to the actual observability tool. You don't need any of those things. OpenTelemetry is completely open source. We don't need to create new connectors because OpenTelemetry has a repository full of connectors to most modern observability platforms. you get to avoid vendor lock-ins. One fine day, let's say APM Platform 1 is your choice of observability tool, and you decide that it's costing you a lot, it is not giving you the visibility a lot. You don't need to change any of your infrastructure. You don't need to change. You don't need to install an additional agent. You just change your OpenTelemetry's exporter piece to export it to the new observability tool you found, and voila, you're all set to go. And the last but most important thing is transparency. You are not installing some kind of a binary which you don't know what is being shipped to the endpoint. We don't know what data is being collected. You avoid all of those aspects with OpenTelemetry because you are in complete control of what is being read and what is being shipped to your visualization system, observability tool, whatever. Now, how do you use observability, OpenTelemetry observability with Hasura? Hasura Cloud and Hasura Enterprise Edition, the self-hosted Enterprise Edition, both now support observability tool. Now I'm going to share my screen. I apologize for the momentary window effect. You have this repository here, which gives you pretty much everything you need to get started on your own observability stack using completely open source tools. We have even built a set of dashboards that are handpicked by individual product owners at Hasura, showing what exactly matters for that specific component of Hasura. We'll go through all of these things together. How do you set this up? I hope my screen is visible and legible for everybody.
That's good.
All right, thank you, Rob. Navigate to settings, OpenTelemetry exporter, enable it, and fill these two new variables here. There will be a third one as soon as 235 is available, which is going to be logs, and add any additional information that you might want, like for example, any authentication headers. If you want to set an environment, let's say you have multiple Hasura environments. One is your production and one is your trial. You can set up environment variables here and click update, and we are successfully exporting. Okay. So now, how do I bring up this? It's as simple as just a Docker Compose file and an environment file. So the Docker Compose file provided in the repository has everything. It has the GraphQL engine. It has a Postgres metadata DB, a data source, a replica, all of those things. You don't need to bring up the entire stack for you to even test drive this. You can enable and disable whichever components you choose to bring it up. And pretty much everything in here is documented. We have even set up a few sample migrations and metadata so that you can get started quickly. Now let's go back to our observability. So this is what the end result of all of that, what we just did, gives you. You get an Hasura overview dashboard. This gives you the highest level look into what Hasura is doing at any given point of time. This combines most of the key observability metrics that Hasura emits. Like, for example, how many queries, what are the latencies of those, how many mutations, or their latencies, subscriptions if exists, any event triggers, cron triggers, all of those things are combined into one dashboard for you to get a quick overview of what is possible with this tool. If you scroll down further, you have your expanded visibility into your request rate, your latency, for both queries and mutation. If you have subscriptions enabled, you have detailed and expanded view into those. Pretty much anything that Hasura emits as a signal, you can add it here. You can track them here. Okay. Now, being the good friendly folks we have given you a set of pre-built dashboards. Like I said, this was built in consultation with pretty much all the product owners. There is two broad categories. General, you get a system monitoring dashboard wherever if you're running this on your self-hosted environment, you can actually see the system parameters, basic fundamental statistics. Are any of your Hasura components down? For example, you might have multiple data sources connected using multiple data connectors. We check the health status of all of those. We check the CPU, storage, memory, swap usage, all of those things here. And you can go into, yes, some of this is showing as failed. Those are on purpose because I have not connected those connectors. You can actually see the communication statistics and the health stats for pretty much all the Hasura components in here. We track them over time. We graph them out in detail so that you can see what happened, when, how, all of those things. And there are specific dashboards for, let's say, Hasura events. Okay. I don't have any events running right now, but there have been events that have run in the past. So you can actually see how many events. Oh, there you go. How many events were triggered and how many were successful. This is a dashboard specifically if you just want to monitor your GraphQL endpoints. You get to see queries, mutations, and their time-based expansion. Hasura Health gives you a comprehensive health check for Hasura itself, data sources, all a latency check for whether or not Hasura is performing. We ping the v1/health-z endpoint and make sure that we get a response, and we chart it out for you. It tracks the number of Postgres connections. We are going to skip the logs and traces because logs and traces is coming as part of 2.35. It should be out, I believe, in a week or so.
That's right.
Yeah. And for OpenTelemetry, the old exhibit meme, we want to monitor our own monitoring solution. So how many traces, how many metrics were sent, and how many have failed. You can see all of those things here. And there is a specific dashboard for subscription. So all of this is built using a select few open source component. And by virtue of them being open source and available for you, and the code being public, you don't have to be limited by what we just showed you here. For example, if you want to set up alerts based on how certain parts of your system is behaving, you can set up those alerts. Let's go here and find out alerting. We have set up some alert rules here, but again, you don't have to be limited by any of these things. So if you go into Prometheus expressions are the easiest way to build these alerts and charts and graphs. Go in there, and if you don't want this to be, if there has been an increase in GraphQL errors over the last 5 minutes, trigger an alert. If you want it to be 1 minute, if you have a mission critical system and you want to be known after a minute, feel free to change that. None of these things, you are free to extend the functionality of this dashboard. You're free to extend you're free to pick and choose whatever components you like. Okay? Again, if you want Prometheus and Grafana, they provide a set of first-class integrations for external plugins. For example, if this alert wants to create an IRP alert, your incident response platform, say, for example, PagerDuty. PagerDuty has a first-class plugin integration with Grafana, which allows you to, when this alert is triggered, set a severity and send it out to PagerDuty, and the alert goes out to your entire organization. And for tracing, yes, tracing you will be able to see once 235 comes, you will be able to see tracing here. So for now, I'm going to use Jaeger to demonstrate the tracing. You can pick and go to the Jaeger UI and pick and choose the endpoint you want to monitor. Pick and choose the endpoint, and let's find some traces. No tracing for the last hour. Let's take for last 2 days. There you go. There are some traces. You can click on here and you get a complete distributed view of where your request spent time and how much time it spent on various components here. As you can see, it hit the endpoint. It spent 97 microseconds to parse the GraphQL. Hasura took another 299 microseconds to resolve an execution plan, and it passed on to Postgres, which spent majority of the time in Postgres before sending us the results back. The same functionality you can, once 235 is out, you can expect in the Grafana dashboards too. Again, all of this is completely open sourced and available for you. Just to give you an example of how you can extend this dashboard, you can go into Grafana dashboards, pick a dashboard you want. Sorry, let's go to a Hasura dashboard. You have everything you need here, and you can just change the code and
Raju, I'm just going to jump in. I apologize, but for our time that we have, that was very detailed. And we know that people can go in and jump and see this entire repository, right? This is available on GitHub, correct?
Yes, sir. I am just posting the repository information in the chat.
Perfect.
All right. Happy observability, everybody. Enjoy.
Raju, thanks so much. Appreciate it. All right, folks, we have our last speaker coming on, which is our community demo this month. We have Raphaël here, who's going to talk to us a little bit about how we can develop with Hasura in our browser using Gitpods. Let me go ahead and bring Raphaël on stage. Raphaël, how are you?
I am doing well. How are you? That was
doing well. Yeah, absolutely. Do you want to give us a little introduction about who you are, your background, and what you're going to share with us today?
Yeah, so I'm Raph. I'm co-founder of Ifimap Creative. We are an impact-driven digital product studio here in Vancouver. And we're also building a framework called the Chewy Stack, which uses a few different services around Hasura at its core. And yeah.
Chewy Stack, I like that name. In that case, I'm going to go ahead and unshare my screen and let you take it away.
Sounds good. So here you can see my browser. We've been using Hasura and Gitpod together for a few years, and we found that both of these tools really improve our velocity. We can just get features out the door much faster than with other workflows that we've used in the past. But there are a few things that make it a little bit more complicated to, or some of the time, Hasura and Gitpod don't play nice together. And so we had to come up with some workarounds to make that happen. So you can see here that I have Hasura up and running, and I've got a database. But if I try to do what you might normally try to do, which is just run the Hasura CLI to get the console up and running, and I go here, you'll see that Hasura console is not able to reach your CLI instance. And the reason for that is that if we go into the network, it is trying to reach localhost, which we do not have available in our browser. And it can be really practical to just check out a PR in the browser, not have to set up your local VS Code, or if you want to just hack on something real quick, it's just practical to be able to do that. It also means that you can get developers on Chromebooks, which is nice in certain cases. So let's stop that, and we will try something else that you might attempt if you're trying to get this done, which is you'll notice in the lovely Hasura documentation that there are parameters that you can pass to the CLI, like the API port and the API host. Now,
keep saying nice things about the documentation. I appreciate that. Yeah.
Yeah, so you'll see that it won't bind. And so if we try that again, it still won't work. But you will see that we're now trying to reach the correct endpoint. So the way that we got around that is that we basically run the CLI twice in Docker containers. So in our Docker Compose, we've got Hasura, we've got our database, but we also have this CLI console and CLI API. And basically here we run the same command that we just ran, but we don't actually expose that port. So we just do 9695, And then here we run 9693 without the bind command, without the API host and the endpoint, and the port. And so when we do that, Docker compose up. So now if I try to refresh this, you'll see that we don't get that error anymore, and we can add a column short text, and we are getting our migrations here in the browser. There's a little bit more to it. We've got a custom Docker file to get the right permissions for Gitpod. But yeah, that's basically how we get all of that up and running. Makes it a lot faster for us to get PRs reviewed, to get especially junior developers up and running. It just really helps out our workflows to get both of these things working together.
That's very cool. Are there any resources that folks could take a peek at if they wanted to try to implement something like this themselves?
Yeah, so let me.
Didn't mean to catch you off guard there.
Yeah, so we've got this one. So I can post the link in the chat.
That'd be great, yeah.
So this is the repo where you can check that out. You'll see that's under GoChewy, and yeah, that's the project. You can go to gochewy.io to take a look at that. It's not quite ready for prime time, but it will be soon, hopefully. And yeah, that'll hopefully get you building with Hasura and a few other services much faster. And you can check us out at goec.io. That's our digital product studio, IFMAP Creative. And we're always so excited about everything that we see coming out from Hasura. It just makes our work so much easier. So thanks for that.
We love hearing that. That's awesome. Thank you so much, Raphael. Appreciate it.
Yep, thank you.
All right, folks. We're going to go ahead and wrap things up here like we normally do. Just as a reminder, for any kind of helpful links, we're always looking for feedback from you folks, whether that's going to be directly, whether it's in documentation, or whether it's any of our open source repositories on GitHub. Feel free to hit us up anywhere along those different paths. If you're not a member of our Discord community, go ahead and use that link down below to join it as well. And as always, if you're a community member and you're interested in demoing like Raph did at the end right there, you can hit us up and we will reach out to you and make something work. So until next time, which I guess will be November, we'll see you folks online. Thanks.